Hi, hello everyone. This is Dr. Brahmayya, Associate Professor, Department of S&H, dealing with the chemistry, MLR Institute of Technology, Hyderabad. Today I am going to talk about types of electrodes, standard hydrogen cell. Types of electrodes and standard hydrogen cell. The overview of the presentation, types of electrodes and standard hydrogen electrode. What are these? We can try to discuss. Types of electrodes. Primary electrodes, metal electrode, metal in contact with its ion solution. Example, Cu2 plus electrodes, Zn2 plus electrodes. How it will be? Zn interacted with ZnSO4. Cu interacted with its electrolyte CuSO4. So this is called metal in contact with its ion solution, metal ion. So the primary electrodes are metal ions. Secondary redox electrodes involve a reversible redox couple. Example, quinhydron electrode. Quinhydron electrode. It is like Fe3 plus and Fe2 plus ions electrode which is mixed with quinhydron. You see here the hydrogen is migrating adjacent carbons of the benzene ring. Here it will be interchanged like this. A solution containing both ferric ions and ferrous ions. A solution containing both ferric ion and ferrous ions due to the presence of this quinhydron with a platinum electrode. Depends upon the taken electrolyte, the secondary electrodes will be formed. And then reference electrodes, standard and stable potential. It is an electrode whose potential is arbitrarily taken as a 0 or is exactly known. So it implies that it is a standard reference electrode which is always used in the electrolyzers to find out the any solution's pH or potentiality, conductivity by using its standard electrode. By using the working electrode, by taking the reference electrode, they will find out the particular pH or conductivity or potentiality of the electrodes. So standard hydrogen electrode SHE, saturated calamine electrode and silver chloride electrode. These are the standard and stable potential electrodes. So what are the uses of these electrodes? This electrode AgCl, the solution is HCl 0.1 molar DMQ. Indicator or working electrodes. By taking the standard electrodes, we will use indicator electrode or working electrodes. The indicator electrode has a potential that is directly sensitive to the concentration of the specific electroactive species analyte in the solution being tested. What is the indicator? What is the reference electrode? What is the standard electrode? We have to know. Standard electrode is always taken as a arbitrarily 0 and is exactly known. And then indicator or working electrode, it is testing the solution whatever you taken with the reference of standard electrode. So these are used in the potentiometric measurements, e.g. glass electrode and ion selective electrodes. So standard hydrogen electrode. What is standard hydrogen electrode? Types of electrodes. Type of electrode: gas electrode, primary reference electrode. It is a primary reference electrode. Components, you can check here. Electrode component, platinum and H2. Electrolyte component is HCl 1.0 molar. Construction. So initially this is the platinum metal. Why the platinum metal is always taken for hydrogen? Actually, platinum can facilitate electrons transfer easily without reacting to the surroundings. It can promote the electron transfer through other atoms. Especially hydrogen is always absorbed by platinum in low temperatures also. Even low temperatures also, hydrogen will be absorbed by the platinum, and platinum can easily mix H2 plus O2 into water. And in electrolyzers, platinum can divide this H2 into H2 plus O2. This is the main function of the platinum. So that platinum is always taken as a electrode, inert electrode, by taking the hydrogen surface. Platinum surface is always a good adsorbent for H2. So construction of the standard hydrogen electrode. So this is the standard hydrogen electrode. What is the construction here? Hydrogen electrode consists of a platinum foil. It's having a platinum foil. This is a platinum wire connected to a platinum wire sealed in a glass tube. The electrode is in contact with the 1 molar HCl and hydrogen gas on atmospheric pressure. This is the on atmospheric pressure. This HCl is 1 molar. Is constantly bubbled. The hydrogen bubbles are constantly bubbled in the instrument. This is the hydrogen pumping, hydrogen bubbles. This is the platinized platinum electrode covered in platinum black, platinum foil. Working. The SHE can act as a anode or cathode. The SHE, standard hydrogen electrode, can be act as a either anode or either cathode. It depends upon the taking of the other electrode, depend upon the half shell that is attached to it. Whichever the half shell we are attaching to that cathode, if you take the cathode, it will act as anode. If you take the anode, it will act as a cathode. If it acts as an anode, then following reactions are happening. H2 can become 2H plus ions and 2 electrons. It is an oxidation. Hydrogen gas liberates 2H plus ions and 2 electrons. It is an oxidation reaction. Representation of the cell is platinum and slash H2 gas on atmospheric pressure and slash H plus ions, aqueous 1 molar. If it acts as a cathode, then the following reaction happened. 2H plus 2 electrons gives rise to H2. Reduction occurs. So hydrogen ion gets hydrogen gas by taking the 2 electrons. This is a reduction reaction. So it's a very standard reaction happening. If you take, depends upon the taking of the other electrode, it will act accordingly. Representation of the cell of the reduction is H plus aqueous 1 molar and H2 gas on atmospheric pressure and platinum. So example of the SHE. Let us consider a cell with a zinc electrode and SHE. Let us consider a zinc electrode and SHE. So we are taking as SHE is 1 electrode and zinc electrode is 1 electrode. Here the zinc metal gives electrons to other electrode. We know very well in the galvanic cell we have seen in the last video, that is it can loses its electrons, that is SHE. Here the zinc metal gives electrons to the SHE. Instead of the copper in galvanic cell, we are looking SHE. SHE is the standard electrode, so it will act as a cathode here. So the H plus ions in the HCl solution get neutralized and form H2S gas. Since the zinc electrode is losing the electrons, is undergoing oxidation, therefore is an anode. So the SHE is the cathode, since it gains electrons, therefore is undergoing reduction reaction. So SHE acting as here is cathode. So voltmeter displays the electrode potential as minus 0.76 volts. See here, this is the SHE, this is the zinc metal. It loses its electrons through wire and it is gaining by SHE. SAC here, and then zinc is acting as a oxidation metal and SAC is acting as a cathode, half cell reactions. So zinc 2 plus ions plus 2 electrons, and 2H plus 2 electrons gives rise to H2. This is a reduction. This is a oxidation. So overall reaction is zinc plus 2H plus gives rise to Zn2 plus H2. So calculation is the electrode potential of the zinc electrode in the zinc and hydrogen cell is standard EMF E0 cell is equal to E0 cathode minus E0 anode. This is already discussed in the last video. This is the formula. So already we have given the notice that 0.76 volts. So E0 cathode is 0, standard cathode. For cathode standard electrode cell, standard hydrogen electrode is 0, taken as a 0. So 0 minus Zn2 plus ions. So finally it will become E0 Zn2 plus equals to 0.76 minus 0.76 volts. This is the measured value. Applications of the SHA. This electrode is used to calculate the electrode potential of the various half cells, and it has no salt errors. The summary. The presentation covers types of electrodes and examples. This lecture also covers the standard hydrogen electrode construction and its working with example. The presentation also covers its applications in the electrochemistry. Thank you.